The James Webb Space Telescope has finally broken its silence, and what it's revealing could change our understanding of the universe forever. For months, scientists have been poring over its data, waiting for confirmation of strange anomalies it detected at the very edges of space. Now, the results are in, and they're nothing short of extraordinary.
From galaxies that shouldn't exist to cosmic structures that defy the laws of physics, Webb's discoveries are shaking the foundations of modern astronomy. This isn't just another space update. This could rewrite the history of our universe. The Webb telescope has detected light from galaxies that formed far earlier than our current models of the Big Bang allow. We're talking about fully developed galaxies existing just a few 100 million years after the birth of the universe, when, according to established science, stars and planets shouldn't have had time to form. These aren't tiny collections of stars either. They are massive, structured, and filled with complex elements. The problem? That level of complexity takes billions of years to develop. Webb's infrared eyes are looking so far back in time that it's essentially peering into the baby photos of the universe and finding toddlers instead of newborns. This discovery forces scientists to reconsider the timelines we've been taught for decades. Could this mean our understanding of cosmic evolution is fundamentally flawed? Or is there something far more mysterious influencing the early universe? In addition to these ancient galaxies, Webb has also captured images of something even more puzzling: massive, interconnected structures, essentially the skeleton of the cosmos, that appear to have formed far earlier than expected. Known as the cosmic web, this vast network of filaments made of dark matter and gas connects galaxies across the universe. The strange thing is, Webb's data shows these filaments already in place just a few 100 million years after the Big Bang. Our current cosmological models say that gravity alone shouldn't have been able to shape matter into such a network so quickly. Could this be evidence of unknown forces at play in the universe? Some scientists are even wondering if these patterns point toward a hidden framework guiding cosmic evolution, something that goes beyond what we can currently detect. The anomalies don't stop there. Webb's observations suggest that the speed of cosmic expansion in certain regions doesn't match what we'd expect from the standard model of cosmology. In some parts of deep space, galaxies seem to be moving away faster than they should, while in others, the expansion rate is slower. This uneven expansion could mean that dark energy, the mysterious force pushing the universe apart, might not be constant after all. If dark energy behaves differently in different regions, it could revolutionize our understanding of physics. Some researchers have even floated the possibility that what Webb is seeing are interactions with other universes, parallel realities, whose gravity or energy leaks into our own. That's not science fiction. It's a hypothesis scientists are seriously discussing as the data mounts. Webb's instruments are so sensitive that they've also picked up faint, unexplained light sources at the very limits of the observable universe. These signals don't match the profiles of normal galaxies, stars, or quasars. Instead, they have an unusual spectral signature, leading some scientists to wonder if they could be the remnants of the very first generation of stars, the so-called population 3 stars that have never been observed before. Others speculate these signals could be from completely unknown cosmic phenomena. The implications are staggering. If these sources are what we think they are, they could tell us exactly how the first elements were forged, how black holes formed in the early universe, and even whether our cosmic history played out the way we believe it did. NASA's long silence about these findings wasn't due to secrecy, but caution. The Webb data is so groundbreaking that scientists needed months to verify and cross-check it. Announcing results that could rewrite textbooks requires absolute certainty. Now that the evidence is confirmed, the astronomical community is buzzing with both excitement and confusion. Some theories will need to be discarded, others will rise in their place. But one thing is clear: the James Webb Space Telescope has proven itself to be more than a successor to Hubble. It's a time machine, a truth revealer, and perhaps the most important scientific instrument in human history. While analyzing the deep field images, Webb found several massive black holes existing just 400 million years after the Big Bang. This discovery is baffling because black holes grow over time, feeding on surrounding gas and dust. Yet these ancient giants seem to have appeared fully formed, weighing millions, even billions of solar masses. How could they have grown so quickly in such a short cosmic window? Theories range from direct collapse of massive gas clouds to entirely new, exotic processes we haven't imagined yet. The strangest part? Some of these early black holes appear to be influencing galaxy formation around them, almost as if they were seeding the cosmos with structure from the very beginning.
Webb has spotted fully mature spiral galaxies at times when the universe was supposedly still too chaotic for such structures to form. Spiral galaxies require billions of years of gravitational interaction to develop their organized arms and central bulges. But these early spirals are as complex as our own Milky Way. Their existence suggests that galaxy formation may be far faster and more efficient than our models predict.
Alternatively, they might hint at a pre-Big Bang era where structures were already forming before our current universe began. One of Webb's strengths is its ability to detect chemical signatures in distant objects. To everyone's surprise, it's finding heavier elements like carbon, oxygen, and even traces of iron far earlier than expected. According to standard cosmology, these elements could only form in the hearts of stars, which would then have to explode as supernova to spread them. But Webb is seeing them in galaxies so young that there hasn't been enough time for multiple star generations to occur. This means either stars formed at lightning speed, or our entire understanding of stellar evolution is incomplete. Webb's gravitational lensing observations, where massive objects bend light from behind them, are revealing unexpected distributions of dark matter. In several cases, dark matter appears more concentrated than predicted, suggesting it may clump or interact differently than we think. Some researchers even wonder if dark matter might not be entirely dark, but could occasionally interact with normal matter in ways we've never detected before. If true, it could revolutionize particle physics. Certain regions imaged by Webb show galaxies and stars that appear billions of years older than they should be, given their location in the timeline of the universe. It's as if parts of the cosmos experienced a fast-forward effect, evolving far quicker than surrounding regions. Could local variations in dark energy, gravitational fields, or even collisions with other universes explain this? Or is it possible that time itself flows differently in certain parts of the universe? Webb's mission includes the hunt for the first generation of stars, known as Population 3 stars. These stars, made almost entirely of hydrogen and helium, would have been massive, short-lived, and incredibly bright. While no definitive detection has been announced yet, Webb has found several candidate signals that match predictions. Finding these stars would be like discovering the Rosetta Stone of cosmic history. They would reveal exactly how the first heavy elements were created. While studying gravitational lensing, Webb has found distortions in light that cannot be explained solely by visible matter or traditional dark matter models. In some cases, the bending is too strong, suggesting additional unseen mass or exotic gravitational effects. Could this be the first hint of a fifth fundamental force of nature? Or are we seeing the gravitational fingerprints of objects that exist outside our universe but still influence ours? The cosmic microwave background, CMB, is supposed to be the same temperature everywhere, with tiny variations. But Webb's ultra-sensitive instruments are detecting slight differences in the heat signatures of early galaxies that don't match the CMB map. This suggests that parts of the early universe may have been warmer or cooler than expected, which could have influenced where and how galaxies formed. In several galaxies, Webb has found dense clusters of ancient stars orbiting far from their galactic centers, sometimes even in intergalactic space. This defies our understanding of how star clusters form and remain gravitationally bound. Could these be the remains of older galaxies, torn apart by cosmic collisions? Or are they fragments from an even earlier cosmic cycle? Some of the earliest black holes Webb has imaged seem to be emitting powerful jets of energy, streams of particles moving near the speed of light. These jets are normally seen in much later, mature galaxies.
Their early appearance could mean that black holes played a much bigger role in shaping the early universe than previously thought, possibly even triggering galaxy formation through their energy output. The universe, on the largest scales, is supposed to look roughly the same in every direction. But Webb's deep surveys are revealing subtle asymmetries, regions with more galaxies, denser filaments, or larger voids than others. These imbalances could be random, or they might hint at something beyond our observable universe exerting a gravitational influence. Webb has picked up intense bursts of ultraviolet and X-ray light from deep space, but without any obvious source like a quasar or supernova. These mysterious flashes could be from collisions between primordial black holes, exotic stellar explosions, or phenomena we've never observed before. The fact that they're coming from the early universe makes them even more puzzling. The leading theory about the Big Bang is that the universe underwent a brief period of rapid expansion called inflation, but Webb's observations of large-scale structures challenge the smoothness inflation predicts. If these structures existed so early, inflation may not have happened the way we think, or at all. This could spark one of the biggest paradigm shifts in physics. In some areas, Webb has imaged faint, diffuse galaxies with barely any stars, but significant amounts of dark matter. These ghost galaxies seem to have formed differently from typical galaxies, and their existence might help explain the hidden mass of the universe. Strangely, some are located where no galaxies were expected to form at all. Perhaps the most mind-bending discovery is the detection of patterns in matter distribution that could be remnants from before the Big Bang. These echoes might be ripples from a previous universe that collapsed and gave birth to ours. While highly speculative, the idea is gaining traction as Webb continues to reveal anomalies that current physics can't explain. Every time scientists think they've reached the limits of Webb's surprises, the telescope delivers more. The data is so rich that researchers expect decades of breakthroughs from its findings. What's becoming clear is that our cosmic story is far from complete, and Webb is only just beginning to tell it. In one deep field observation, Webb recorded an inexplicable halo of faint light surrounding a distant cluster of galaxies. This glow wasn't coming from any visible stars or gas. It appeared to be a diffuse background illumination. Some scientists think this might be orphan light from stars stripped out of galaxies during collisions. Others suspect it could be the signature of an entirely new type of luminous matter. If confirmed, this discovery could change how we measure light and energy in the universe. Among the most puzzling finds are enormous, colder-than-average regions of space, far larger than any single galaxy cluster. These cold spots appear as though something massive is draining heat, or perhaps never allowed heat to form there in the first place. One daring theory suggests they could be scars left by collisions between our universe and other universes in a multiverse landscape. Webb's sensitivity allows astronomers to study them in unprecedented detail, but the mystery deepens with every new image. In the faintest, most ancient regions Webb has observed, some gravitational effects hint at small but extremely dense objects, potential primordial black holes formed just fractions of a second after the Big Bang. If they exist, they could account for some or all of dark matter. They might also have served as the seeds from which galaxies grew. Proving their existence would answer decades-old questions about the earliest moments of cosmic history. Webb has revealed galaxies so bright they defy explanation, emitting light equivalent to hundreds of billions of suns. Their luminosity suggests hyperactive star formation rates or enormous black holes feeding at incredible speeds. But the real shock is how early these monsters appear in the timeline, again challenging the slow, steady growth model of the cosmos. Some researchers suspect these might be powered by entirely new astrophysical processes we've never seen before. An eerie pattern is emerging in Webb's deep space surveys. Certain elongated galaxies appear to align their axes in the same direction, even across vast distances. Standard cosmology predicts such orientations should be random. Could this be evidence of a large-scale cosmic field influencing galaxy rotation? Or is it the gravitational fingerprint of something immense lurking beyond our observable horizon?
Webb has captured snapshots of galaxy mergers happening in the early universe at much higher speeds than expected. These rapid collisions would have violently reshaped galaxies, creating bursts of star formation and fueling massive black holes. But why did they occur so soon after the Big Bang and at such breakneck velocities? This could hint at a denser, more chaotic cosmic environment than we've ever imagined. Perhaps one of the most astonishing discoveries is star formation taking place in regions far removed from any galaxy, deep in cosmic voids. These isolated rogue star nurseries challenge the idea that stars need dense galactic environments to form. They might be relics of smaller structures that never grew into full galaxies, or perhaps fragments from catastrophic galactic breakups. Quasars, supermassive black holes emitting intense radiation, were expected to be rare in the early universe. Yet Webb is finding them in abundance, some with unusual emission patterns that suggest either unique feeding mechanisms or unknown physics in their accretion disks. These early quasars might hold the key to understanding how the first galaxies evolved so rapidly. In certain Webb images, some early galaxies appear to be surrounded by enormous, faint rings of gas and dust.
These rings could be the remnants of past galactic mergers or the shockwaves from colossal stellar explosions. Their symmetry and size, however, are hard to explain, leaving astronomers wondering if they're looking at a process entirely unfamiliar to us. One of the quieter revolutions sparked by Webb is its ability to help trace cosmic magnetic fields in the early universe.
The data suggests that magnetism may have been far more widespread and influential during galaxy formation than previously thought. If magnetic fields shaped the first cosmic structures, our entire understanding of early star and galaxy birth could need rewriting. Webb has spotted galaxies that are unbelievably small, just a fraction of the Milky Way's size, but containing a huge number of stars tightly packed together. These ultra-compacts seem to have formed rapidly and burned through their star-making material in record time, leaving behind dense relics. They could be the ancestors of modern elliptical galaxies, frozen in time. By studying gravitational lensing, Webb has captured the same event, like a supernova, appearing multiple times due to the bending of light paths.
In some cases, the delays between these appearances are longer or shorter than expected, suggesting that our understanding of space-time curvature in those regions is incomplete. This could open a new way to measure the universe's true expansion rate. Dust may not sound exciting, but it's critical to star and planet formation. Webb is detecting vast quantities of cosmic dust in the very early universe, far sooner than standard models predict.
The sheer amount implies that the first generations of stars must have lived and died in rapid succession, pumping heavy elements and dust into space far faster than we thought possible. By analyzing exoplanet atmospheres in other star systems, Webb is finding more planets in the habitable zone than anticipated, places where liquid water could exist.
Even more intriguing, some planets orbit stars far older than our Sun, meaning life could have had a multi-billion-year head start elsewhere in the cosmos. Webb's instruments have identified massive clouds of pure hydrogen and helium gas, with almost no heavy elements, likely the raw material for the universe's first stars. Mapping these clouds could give us a step-by-step blueprint of how matter transitioned from simple gases into complex cosmic structures.
Supernova explosions usually scatter material into space chaotically, but Webb has found remnants that are eerily symmetrical and intact, as if something, perhaps strong magnetic fields or even exotic matter, held them together. This observation is forcing astronomers to reconsider how some stars die. One of Webb's goals is to study the epoch of reionization, when the first stars and galaxies lit up the universe and ionized the hydrogen gas around them.
Surprisingly, Webb's data suggests this process happened unevenly, with some areas lighting up much earlier than others. This irregularity could point to hidden cosmic influences or vast early black holes shaping their surroundings. Some of the oldest galaxies Webb has observed seem to carry faint gravitational imprints, ripples in spacetime, from massive black holes that existed even earlier. If confirmed, these could be the first indirect detections of black holes formed almost instantly after the Big Bang. After only a few years of operation, the James Webb Space Telescope has transformed our picture of the cosmos. But perhaps its greatest revelation is just how little we truly understand. Every answer Webb provides seems to open up 3 more questions. And as more data pours in, humanity might find that our place in the universe is stranger and far more extraordinary than we ever dared to imagine. Webb's deep field surveys have revealed vast stretches of space where, according to our models, there should be galaxies, but there are none. These dark gaps are larger and emptier than cosmic voids predicted by simulations.